So the first thing I want to do is make sure that we actually slow them down. They have a lot of energy, and I'm going to do that in two different areas. The first one being the velocity that we're setting. So here we're setting the velocity. I'm going to reduce these values 4.8 to 3.6. This will give us less energy. Another thing we can do, and this is something that we actually already did on the blast pop solver, it was that the time scale, we reduce the time scale 0.8. That's going to help. And finally, pop drag. Let's create a pop drag. This will definitely slow things down. Let's start with, yeah, let's leave it like this. Good, switch to a side view or something so we can have a better look at what's happening. So this is an issue. We don't want the pop drag to apply to the particles that are being emitted right away. The idea is for us to have the pop drag only affect the particles that actually collide with the object and ricochet in multiple directions. The way for us to do that is to actually make use of the pop collision detect. With the pop collision detect, we can pretty much do what we were doing with on the pop solver, where we have the ability to set a group for the particles once they collide, for instance. So the collision target is going to be the same thing we're using here on the static object. So we can just Control A, Control C, and paste the path here. Use the following geometry. No need to watch the guide. The next thing is on the behavior group name, let's say collided, same as before. Let's preserve the group. We don't want to color the hits, and we want to compute hit total. The response is none. We just want to detect whatever's being whenever a collision occurs, and we want to make sure that we have access to the group of particles that have collided with something. Now that we have that, we can go to the pop drag and set the group to be collided. Let's hit play, and now we should see that the particles are not affected by the drag. Once they collide, they do not expand as much as before. You can switch to the camera from the back, and you'll see they're no longer bursting as much as before. They slow down pretty much after being hit. Okay, let's make sure we actually have everything working, and the easiest way for us to do that is to color the hits. Let's go to the guide. We cannot have the visualization on, otherwise it won't appear with the proper color. And let's see what's happening. We should see the particles that collide turn red. It's most of them. Exactly. And the drag is having its effect. Okay. Notice the size of this at frame 27. If I disable the drag and go to frame 27, we should see a lot more scattered. There you go. There's a clear difference. So let's keep the pop drag. The next thing I want to do is make sure that at the end of the particle's life, and let me make sure that we're actually aging the particles. So volume source, life expectancy, and life variance. Let's turn that on, and let's put here 1 frame and here 0.4. 1 frame, no, 1 second, sorry, 1 second and 0.4. The next thing is going to be for us to make sure that by the end of the particle's life, they will be more affected by the advection volume. So again, this is something that we're going to be reusing from the pop network, where it just grabbed this pop effect by volumes. It's already working with a normalized age. So you can Control C, Control V, and use this. And yeah, we're pretty much ready to give it a first test. Let's set up the cache elements. So once we go here, you could use a top import field. That's something we could do. Top node, sorry, it was the top network, goes into the top network, and then you choose flip fluid, and we have everything we need. The top node is going to be the flip object one. Change this back again, flip fluid, and we're going to have all of these. Okay, it's showing the top import field working properly. Or we can just simplify things, not go with the, and just use the top network and type here flip object one, and we'll be using the geometry. Whenever I can keep things simple, I tend to keep things simple. I'm gonna go back, make sure that this is actually disabled. So I do want to see the speed, and here on the pop effect, the collision detect, I'm gonna turn this off. Let's go up. So we have the flip object. Let's advance a few frames. Maybe a few more. And the only particles that we're actually interested in are the particles belonging to the group collided. So we're gonna do a blast. I'm gonna blast the collided particles, or everything except the collided particles. And this is what we're gonna be getting. Just the burst of energy that we need to add to our already awesome blast. And as you can see, after they burst, they kind of go into the same motion that we had on the blast particles. Okay, really cool effect to add to the blast that we already have. So let's just move a few frames forward. I want to use the same attribute delete. Let's reuse these group delete, attribute delete. I don't think we need anything else from here. And I'm also going to copy the blast, the file cache. It's going to change the name to blast B. Make sure to update the base name here, because by default the value is going to be $OS, but once you save, it kind of bakes the name. And I think that's it. Let's go to version 1. It's pretty much ready to go. I'm gonna save the file. I don't think I forgot anything. Let's give this a try and see how it looks. So I'm just gonna simulate the whole thing, cache the whole sequence, and we'll come back in a few moments. Just hit save to disk.